Very good morning to students. Today we are going to learn about the mind supports, various natural supports and mind supports uh, from the early classes concern. Right. Uh, Today topic is actually in rock mechanical strata control in mind supports. The topic is mind supports. Uh, Basically, from the design of supports based on the RMR and based on the uh, pressure arch theory, we come and one conclusion that the the zones of separations um, by the pressure arch theory we can identify by RMR how much load can be expected in galleries, based on that one, which type of supports you are using. Generally we have design of pillars are the nature supports that will be as per the Benwski equation, the strength of pillar and tributary concept, development activities going on. Based on RMR and pressure arch theory, based on the supports are erected in different locations from the face to the gallery, and also mm, air ventilation galleries, and also the man roadways, and also the from the shaft mouth to the face. So these are the different supporting requirement in mines are uh, required. General as per the principles of supports requirement based on the rocks available in the coal mining area, sandstone, shale, kale, and coal seams. Um, uh, the before excavation, uh, done in an underground mine, rock is as in situ or subject to vertical and lateral pressures that we well know that one, which are in equilibrium in nature. The vertical compressive force and the effect of P1 is to be compress the rock in a vertical direction, and the strata are not able to expand it sideways. There is a induced lateral compressive forces along the beds denoted by P2 when an underground roadway is made in the mine. The equilibrium of the pre-mining forces is distributed, and there is a redistribution of the vertical and lateral pressures. New kind of forces also come into the play. This redistribution of the pressures is a it is called as the explicit pressure arch theory. So we well know that from the pressure arch theory, uh, the separation and the load acting on immediate proof. Zone 1, zone 2. Zone 1 is the bed separation, and bed no bed separation some area. Origin in the vertical pressures, floor of the bench. So the overall the pressure on the coal pillar is also transmitted in the floor of the coal. That is also we know. The width of excavation increasing span of the pressure also increasing. The various the immediate roof is roadways or working places in the coal seams may consist different way. So now coming to the our today lecture is concerned, the man-made structure erected in mines to prevent the cave-ins and heaving of the surrounding rock to the pressure, the required dimension of the mine cross section, and observed and control the rock pressure. When the peripheral pressure is present, the wall of the arch supports are made of the cantilever. So why do we support mines? Keeping miners safe, that is the first factor. Ensure continuity of the ore production to avoid the shortage in profit. Finally, keeping expensive missions in underground mines safe. Example, mission used in the longwall mine. So keeping miner safe, ensure the continuity, and final keeping the expansion missions. So underground mine safe is a very our motto. the basic prime motor of as a mine supports required. So when do we need to support mines? If there are weak or unconsolidated parts of the rocks are present in the roof and wall of the mines. If there is some geologic structure, example shear zone that we can rock. If there are voids and spaces in the rocks, if there are some clay beds that can be shrink and expand due to its swelling property, hence sliding of rocks in the presence of water can be expected. If there are underground water that help in chemical, whether leading to loose rock and corrosion of missions. So these are the when you need of the supports in mines particularly. So these are the points, major points of need of supports in mines. The causes are given here. So the weak and unconsidered parts, there's some geological structures and the wider space in the rock, clay beds, and that can be shrink and expanding, underground water that help in chemical. So here some right. Then there are five type of mine supports are there. In generalized, the phenomena of these things. One is a wooden logs supports using metal rods, support using metal pins or roof bolts, support using metal fencing, concrete supports, and using the brick walls. So another properties of the various type of roofs are there. Based on that, the supports are classifications are there. Uh, the roof common. The testing of roof is also the material employed in support particularly. The timber usually saw and some areas the teak is used for the props, bars, chalks, or cocks and laggings. By using the only wooden is there, but wooden can be used as a different fashion. So wooden logs or supports are used as a timber. Props are bars, chalks, cocks, and loggings. That is one category. And also support using metal rods. That is steel, iron and steel in the form of bars, props, arches, corrugated sheets, and roof brawls. These are the another types of material using in the supporting material. Bring building a stone in masonry walls or arches. Reinforced concrete or precasting concrete blocks as a roadway lining. Roadway ripping, dirty bands and other shades are pack walls. Sand, earth, boilers, ash. Washery rejects milling, mill tilings, slag from blast furnaces for smelting iron and crushed stone as a packing of a goof and filling of and or voids. So, research into the strong, lightweight materials for underground supports has shown that the most promising one is a glass fiber reinforcing plastics. So these have not been introduced in our minds. As that test in so many countries, Russia and other countries, uh, precast concrete assemblies or support have been also sent and using in our minds. They have serious disadvantage, great weight and difficulty in handling in the undergrounds. The type of supports are built up depending on the importance of place to be supported, the period of the supports, its cost and availability. These are the generally uh, seen in the different category of supports. So this is one example. Wooden log supports different fashion they are showing. Please see that the picture, beautiful picture is showing here. And then uh, wood logs trucks and should be straight and about 4 to 6 meter long. Evergreen trees are recommended. Uh, Pine trees, iron wedges, most be used to fix the wooden logs. This is wooden logs. Most of the metal mines, this type of usage of wooden logs. Uh, Advantages of wooden logs are some advantages are some disadvantages are there. Cheap even when it is imported from the abroad. Can cut it the desired length. Give early warning when it is shallow. And designed wooden trucks cannot be received in other mines. If who follow another type of mine support should be applied. Most of the presently wood is not using due to the accuracy of the forest restrictions. Presently, most the mines are iron-based supports are using. This is support using for metal rods. Simply, it is a metal rod consists of the two cylindrical and different diameter length. Uh, Length can be controlled using pins and moving upward and downwards. Advantage disadvantage of metal rod supports. Rods can be easily be reused again. Example in other mine. Length height can be easily controlled. Give high support capacity. Expenses does not give the early warning like wood trucks, moisture and mine water can cause corrosion of metal. Supports using metal pins or roof bolts, usually used for the ceiling only. A1 and 1.5 meter hole is needed within the 1.4 centimeter diameter bolts, and pin must be have ripped from the supports. Uh, the advantage and disadvantage of the metal road supports. Necessity for a ceiling that have weak fractures in the hard rock, high support capacity. Supports using metal pins are roof bolts. Uh, these are the roof bolts, ball type and standard types. This the different roof bolts are using for iron based physics. This is most of the mines using because of the maneuverability movement of the vehicles is possible. So this is a new invention in the robot is concerned. So expansions were not suitable for soft rocks. Moisture and mine water can cause corrosion of the metal. These are the other hand of disadvantages of the when using in metal type support systems. Supports using metal fences usually used for sill only, especially in case of rock falling. Metal mines pins need to fix the metal fins. Can be used for wall also, but if clay beds are messed. So these are nets type of most of the long wall face areas. These meshes are presently using. That is also rusted or something is happen. Advantage and disadvantage of the metal fencing supports. Necessary for the ceiling that have weak fractures in the hard rocks. Give early warning in case of mine collapse. Collected falling rocks. Reasonable support to capacity. So expanses are not suitable for soft rock. Moisture and mine water can be cause of corrosion of metal. So classification of pillars. Square and rectangular pillars. Presently, you are using the natural supports is concerned. Square and rectangular pillars are using long wall pillars or irregular pillars or rib and crown pillars, safety and barrier pillars. Square and rectangular pillars, these are the integral part of the room and pillar mining. Design is based on the uniaxial stress from the super incumbent load. Common in flat dipping mineral deposits, where the horizontal span exceeds the critical span. A vein seam allows once pass mining. Overlying strata cannot be support itself without a strong pillar. Application include coal, potassium, uranium, copper. Um, a long pillar, internal part of the slot mining, a variant of the room and pillar mining method used in gently dipping ore bodies, also called stop and pillar mining in the Canada. A room and pillar slot mining is in Australia. If ore too thick to be mined in one pass, ore is extracted by benching, roof span, and pillar design. It is similar to that of the room and pillar design. Pillar either fall as a result of the rock burst or a progressive slabbing at a pillar sides. So irregular pillars are common to old methods such as a breast stopping. Pillars are randomly placed. Design follows the principle of room and rectangular pillar. Locations are depending on the ore grade. Pillars are restricted to low grade and areas of bad ground. Rib and ground pillars, these structures provide the supports in a manner similar to the room and pillar operations. The geometry is different since the pillars are common to speedy dipping ore bodies, where open fill methods are used. For example, cut and fill method, ribs and grown from the skeleton around the stove. Secondary recovery is common as not more than 50% extraction is possible in the primary mining. Rib and grown pillars, stopes are filled before secondary mining. Ribs and grown supports can be approximate as a series of the column supports is a panel. Pillar's load depends on its position related to the center per panel, where the maximum deflection is occurs. Protective pillar, these pillars protect the surface and underground structure due to the pillar failure, they can classified as a barrier pillar, protect the active mining area from the adverse effect of the nearby mining. Normally, highly stress is extended to the hanging and footwall rocks. Be careful while designing nearby openings such as a haulage drifts. So safety pillars, solid ore blocks are left intact beneath the surface structure to protect the structure from the substance. Size is determined on the basis of allowable surface displacements for the structure overhead. Soft pillar, protective shafts, the design should take into the account ground movement induced by the nearby mining. This is the one view of extraction methodology. Uh, Room and pillar, the generalized method of working is showing here. This is another method of natural support. These are the uh, design of supports, and also room tune bed pillar. So it is nicely narrated here. How this what you call this is a prop, wooden props, how to erected in the areas. I'm going to show you here. So timber is the most supporting. Timber is the uh, commonly used material for support in the mines as a cheap and easily available dry and seasoned saw props and bars are used in some parts of the area also. Presently, these are props due to their erection problems. Most of the hydraulic props are most of setting of props when erected in a mine to support the roofs up should be yield slightly under the roof weight. The timber prop is strong when the uh, load act parallel to its length. Prop as such almost unyield, but a certain yield obtained by the tampering it at the foot or tap, providing a lid on the top of the prop as a compressible cushion between the roof and end of the prop. In a flat seams, the prop is erected vertically and inclined seams. Axis of the prop should be normally to the tip of the seam. The prop then offer the maximum resistance to the roof. A prop which is so set that it exacts between the vertical and normal to the seam is known as a underset prop. Erection underset prop is not common. It is possible to for the timberman to judge whether it is a underset or not. Prop should be set on a solid floor and not on the loose packing or debris except in case of emergency. If the prop has to be set on a loose rock, loose coal or sand pack should be placed on the flat base pieces not less than 5 centimeter thick, wide and long. Timber prop is expected to support the roof area in about 0.4 to 1 meter long. The props are erected in an odd floor in the seam of the varying thickness, roof height up to 2.5 meter, roof height up to 2.5 to 4.5 meter. Different sizes, different areas, different conditions. More than 4.5 meters also, the prop can be used. This is another sections of the roof bolting. This is going on in on uh, meshing also given. Here you can observe the mesh also, iron mesh and roof bolting activity, universal testing roof bolting. At a time, their bolts are fitting to the this views can be observed. This is a one of the view of there's a track and wooden support systems in the working area, particularly gallery. This is another prop setter, welding timber supports. This the mesh is also given. The lid is provided here. These are the bars. Iron bars are erected. Generally, bars are particularly uh, the combination of timber bars are there. Bars act as a beam. A timber bars is placed in the holes of minimum depth of the 500 mm in the side of the core pillar. Uh, side of the core pillar. Uh, side of the core pillar. If the sides are strong, the sides are weak, the bar is placed on a vertical prop. If the bar is circular in cross section, the top end of the prop should be hollowed out to fit the contour of the bars. Alternatively, the bar may be flattened at each end so that the end can rest on the flat ends of the prop. The bar should always be tightened against the roof and should offer the maximum area of contact against it. The sides of the bar towards the roof is chopped off flat for this purpose. The flat wooden loggings are also used if the roof is uneven. So this is one of the advantage of the bars is concerned. Most of the iron gutters are using because of this gallery, which is more widened. In such cases, the iron gutters are most of them. Most of above 4.3 meter sites, more than 3 meter height also sometimes due to the loosened ground. In such case, also gutters are very suitable for us. This is also prop. These are showing here. And this is a chalk is given here. This is most of this is a combination of sleepers erected in the most of junctions. At the junctions, it is a most this application is more, but more space will be occupied. That's the one of the problem. But more yield can be accepted, and also indication is also giving. The erection will be some of time consuming, time taking thinking. So see that this is a chop. Erection of chalk is also an important original roof is connected to the floor to floor. The square members, 100 mm to 100 mm square members are wedges are convergence roof is very much. 20 tons load is acting on the particular roof. Supports the wooden cocks and chalks. A chalk and cocks or chalkmates is a combination of sleepers above one another in a crisscross manner. This is a crisscross manner. This is called as a crisscross manner, criss and cross manner. The crisscross manner, as shown in the figure, it supports a much larger stretch than a prop, and it is used a place where the roof is bad over a wide area and need a substantial supports. The cocks are also erected where the main roadway have to pass through the area, having coal pillars in adequate size. The term chalkmate is generally used in the metal mine. Cocks are required under the regulations at GOFET at junction of the splits and galleries in a depillaring area, in a board pillar working and or break off line at the goof of the long wall face. Only rectangular sleepers or alternatively sleepers have their. The cock should not be normally erected in the loosened floor or debris, but as a natural floor of the secure foundation. The required foundation is required. The floor area over which the cog is to be erected may be excavated for a depth of the 25 to 50 mm and should be made nearly flat in seam and a mild inclination. Members of cogs are placed at a right angle over the members immediately below in the pairs. The cog chocks is a tightened against the roof by hammering wedges in its convenient height. When the withdrawing a chalk, withdrawal of such a weight to loosen the chalk and withdrawal of the slipper become easy. The chalk should be tight against the roof, and then this may be tested by hammering for loosen the uppermost slippers. In some cases, the chalk is erected in between four corner props, such as corner props are generally not necessary except where the roof is very bad, go for edges or gallery at the junction of the galleries, and if the floor is a steeper in 1 in 5, where the corner of props are erected. One sleeper of the chalk is always placed outside the prop. Withdrawal of the member help the dismantling of the chalks. So suppose these are the better the chalk way where erections are going on. The roof bolt. This is a mesh. The mesh over the way the loose material can fall down. These are the uh, drills. Roof bolt drills are erected. So small pieces cannot be fall down into the work. Most of the continuous miner area and in long wall area, these type of meshes are using. So next, this is the how mess over the bolt is erection. Uh, the strategy of this one is small pieces cannot be fall down to the working areas or where the persons are moving. That will be protection of the furnace. And roof bolting is binding the all the areas, particularly there is a number of theories are there. Keystone theory, um, according to lamination theory. Yeah, the complete above area immediate roof is binded by the um, one roof bolt, 6 feet roof bolts will be binded. So these are the double strap systems. The roof, uh, how the maneuvering of the duct is provided in one corner and belt conveyor is going on. So over the roof is completely roof bolted and supported by double straps. This is and including sides also here given. So sides also double straps are erected. So this is a well planned supporting system for convenient for the belt conveyor. Continuously, if any erection is there, props or chocks, that will be interrupted to the movement of the conveyor system. So this is a good roof conditions where the loose corners and the area it can be suitable for the belt conveyor transport system. So these are the different row bolt and the square plates also is given here for the strengthening of the particular row bolts cannot come outside. The tightening against the roof that is showing here. So this is a view of complete roof bolting in a roof bolting cable bolting tender support system, a four coiling spile umbrella arch, and a short created lining, stylist girders showing the complete the safest gallery. The how the three-dimensional view is showing here. So these are the junctions. These junction supports, particularly where the particular such supports of junction straights, where the roof or roads are bad over some distance, where resting horse, core pillars, and tightening against the road The wooden loggings may be erected at the interval of 2 to 3 meters. Uh, if the coal pillars are not strong enough or the road is through the fault zone, the wooden bars are supports in the timber props. This is a common practice where the roof pressure is likely to be heavy bars, may be supported in timber chocks. So heavy junctions at that one, these type of support systems are using. This is the one model for the junction supports. This is a chalk and a prop location at pole face with flags. This is another model. Drift off or stroke, loose ground, open safe field with odds and ends of the old, stalls logging extra, spikes and wedge needed, floor level up to stall. Stall nothing but a wooden logging. The wedges are prepared, angle of under footboard if necessary. The wedge is erected. That's also giving the yield indications of the how much load acting on a particular line. This is the bridge block, side block, spaced relieving side pressure, blocking records, bridge block spalling. May have to put in a stall, hold post apart, side spalling, top spalling. Uh, Simple stall supports, spikes and spreaders, color brass, spikes. These are the complete expansion of board types, complete showing here for the purpose of understanding group supports. So this is the wedge type. So expansion shell type, there will be against wall of the hole against a hole. It will be tightened. This is slot and wedge type expansion shell type. Wooden plates are there here. Wedge type bolts are there. So this is the reinforced concrete rope bolt. Section is given here. And another is so this is a complete ground pressure, so pressure arch. How would be tightened by the rope bolting. This is showing that ground pressures also here. So with this, I hope you are understanding the various natural and norm using of the various supports for the various places and its application. I think you are getting to the all the points in well. I wish you all the best. Thank you.